Good afternoon, students. Today we discuss a topic on ionic polarization. The polarization laye idu vandu second type. Nethu we will discuss about yesterday discuss about the electronic polarization. It's be randomly polarized in all dielectric materials up to the very lower frequency to up to the 10 power 18 hertz. Is in it. Ionic polarization is a less than optical range of frequencies. The ionic polarization process has been occurred. Okay, but that is nothing but the displacement of the anion and the cation is going to be displaced through some distances. So because of this elongation or compressions of these cations and anion direction, so there will be a dipole moment is going to change. So in this way, the ionic polarization has been occurred. So this is a diagram. This is a diagram for ionic polarization techniques. So this is actually without doing the applying electric field, the positive and this here the symbol denoting the positive charge, the black circle denoting the negative charge. This is actually the vibration. This is a vibration between the positive and negative ions going to be fixed. So if you're not applying electric field, is going to be fixed. If you apply the electric field is not equal to zero, you have to apply some field through this direction. So there is some displacement is possible. During this displacement, there is some ionic polarization process has been occurred. Okay. So let us discuss in detail in this session. So today, objective of the talk is the introductions about ionic polarization and followed by some theoretical ideas. Okay, to calculate the polarizability constant. Finally, summary of this today's idea. Okay, so here this is actually D naught. The D naught will be nothing but the separation between positive and negative charges is placed fixed. So if you have to apply that particular electric field to the dielectric material of the ionic substance molecule, the ionic movement is going to be displaced through some distance D. This is actual distance. This distance is going to be extended in this way. So this polarization, this charge particle can try to move through the particular original place, original equilibrium distances. So from that, there is a force can be exist. The force can be exist. The polarization as well as the polarization has been occurred. Okay. Right. But the ionic polarization is a phenomena of displacement of cation and anion in opposite direction and occurs in ionic solids. It made the displacement of cation and anion in opposite directions. Actually, positive and negative charges வந்து ஒரு குறிப்பிட்ட செப்பரேஷன்ல இருக்கு. ஒரு எலக்ட்ரிக் ஃபீல்ட் அப்ளை பண்ணும்போது ஆட்டோமேட்டிக்கா என்ன ஆகுது அப்படின்னா எலக்ட்ரிக் ஃபீல்டோட டைரக்ஷன்ல பாசிட்டிவ் அயன்ஸும் அதோட ஆப்போசிட் டைரக்ஷன்ல நெகட்டிவ் அயன்ஸும் டிஸ்பிளேஸ் ஆகும். அப்ப இந்த டிஸ்பிளேஸ்மெண்ட் ஆகக்கூடிய அந்த சிச்சுவேஷன்ஸ் வந்து இது எங்க நடக்குது அப்படின்னா அயானிக் சாலிட்ஸ்ல அதிகமா நடக்கும். But the displacement is independent of temperature. இது வந்து even though if you have to increase heating the substances, if you have to apply the high electric field, there is a ignoring that particular temperature increases on the surroundings. Okay. இப்போ இது வந்து எங்க சாதாரணமா நம்ம கோவலன்ட் கிறிஸ்டல் டைமண்ட் கிறிஸ்டல்ஸ்ல இது வந்து நடக்காது. It doesn't happen in the diamond crystals, covalent crystals such as a diamond. டைமண்ட்ல இந்த கிறிஸ்டல் ஏன்னா டைமண்டோட கோவலன்ட் மாலிகூல்ஸ் கோவலன்ட் மெட்டீரியல்ஸ்ல இந்த மாதிரியான ionic separations வந்து நடக்காது. Suppose an electric field is applied in the positive x direction, the positive ions is to the right and negative ions to the move to the left. ஒரு பாசிட்டிவ் டைரக்ஷன்ல நம்ம அப்ளை பண்ணும்போது அதோட பாசிட்டிவ் அயன்ஸ் வந்து ரைட் சைடும் நெகட்டிவ் அயன்ஸ் லெஃப்ட் சைடு மூவ் ஆகுது. அப்ப there are supposed to be just considers one cation, one anion in ionic solids. அயனிக் சாலிட்ஸ்ல ஒரு அயன் ஒரு கேட்டயன் இருக்கிற மாதிரி வச்சுக்கிட்டோம் அப்படின்னா But due to ionic displacement, but there is a small induced dipole moment has occurred. Therefore, induced dipole moment is nothing but mu is equal to E into x1 plus x2. E is a charge of the electron. X1 and x2 be the equivalent distance of the movement of the positive and negative ion respectively. This x1 is positive ions of the movement, actual distance on the movement. X2 is negative ions of the movement. Equilibrium separation of the காட்டுது. Okay. But due to static electric field, the force produced may be taken as F Newton. ஒரு static electric field அதுல கொடுக்கும்போது ஒரு F Newtonங்கிற force கொடுக்குறோம். And the restoring force of positive ions is going to be beta 1 x1. Restoring forceங்கிறது தெரியும். ஒரு simple harmonic oscillatorல ஒரு just oscillation கொடுக்கும்போது அந்த அந்த simple harmonic oscillator வந்து ஒரு குறிப்பிட்ட இன்டர்வல் வரைக்கும் என்ன செய்யும்னா அந்த டோட்டல் எனர்ஜியை பூரா எமிட் பண்ணும். அப்போ திஸ் இஸ் கால்ட் ரீஸ்டோரிங் ஃபோர்ஸ். அப்போ இந்த ரீஸ்டோரிங் ஃபோர்ஸ்ங்கிறது எவ்வளவு எனர்ஜியை சேர்த்து வச்சிருக்குதோ அதை வந்து ஸ்பெண்ட் பண்ணி பழைய பொசிஷனுக்கு இஸ் ட்ரை டு கம் டு த இனிஷியல் ஸ்டேஜ். ஓகே. But therefore the restoring force constant is of positive molecule is beta 1 x1. The restoring force of negative molecule is beta 2 x2. அப்போ beta 1 beta 2 be the force constant which depends on the mass of the ion and the angular frequency of the molecule in which the ions are present. Okay, the force constant எதை டிபெண்ட் பண்ணியிருக்குன்னா மாஸையும் அதோட ஆங்குலர் ஃப்ரீக்வன்சியும் டிபெண்ட் பண்ணியிருக்கு. இப்போ நார்மலா வந்து இப்படி மூவ் ஆகும்போது that will be creating the vibration, that vibrations is denoting the angular frequency. அப்போ therefore each one of the force constant, restoring force constants associated with the mass of the ion as well as angular frequency of the ion. But therefore, under the equilibrium conditions, F equal to beta 1 x1 equal to beta 2 x2. So we can generalize that expression. ரெண்டோடைய force constant ஒன்று தான். ஏன்னா because we got to giving a stress to the particular molecule would be the same. So F equal to beta 1 x1 equal to beta 2 x2. Therefore, the total force exists on the positive and the negative ion should be the same. Therefore, from that expression, x1 will be calculated as F by beta 1. Here, F is nothing but an electric force. Beta 1 is a restoring force constant. Therefore, F equal to F is connecting with the charge and electric field. F is equal to E into capital E. That a capital E denoting the electric field present on the molecule when E is a charge of the atom. Here beta 1 is expressed as m omega naught squared. M is a mass of the positive ion. Omega naught is nothing but the angular frequency of the positive ion. Okay, right. Further, F equal to E into E for the beta 1 equal to m omega naught squared. Therefore, similarly, negative ion will be expressed as x2 is equal to E by m capital M into omega naught squared. For capital M denoting that the mass of the negative ion and omega naught is the angular frequency of the particular negative ion. Okay. So, if you are to adding that x1 and x2, the actual displacement has ordered like this: x1 plus x2 is equal to E by omega naught squared into 1 plus capital M plus 1 by small m. Oh, okay. So just substituting that value in that expression, induced dipole moment mu is equal to E into x1 plus x2. So it just multiplied with that value x1 plus x2 into E. இப்போ x1 x2 பதிலா இந்த வேல்யூவை சப்ஸ்டிட்யூட் பண்ணும்போது E squared E by omega naught squared into 1 plus capital M by 1 plus small m. Therefore, alpha I from that quantity alpha I will be denoting that, just relating that the induced dipole moment is nothing but alpha I into E. Therefore, alpha I equal to mu by E. mu வந்து இருக்கு. E ஆல டிவைட் பண்ணும்போது E கேன்சல் ஆயிருது. Therefore E squared into omega naught squared into 1 plus capital M by 1 plus small m. Okay. Therefore, this value will denoting that ionic polarizability of that media of the ionic molecule. The ionic polarizability is inversely proportional to the square of the natural frequency. இது வந்து ஆக்சுவலா ஆல்பா ஐ வந்து எதை டிபெண்ட் பண்ணியிருக்குன்னா is inversely proportional to square of the natural frequency and also the reduced mass. So this value 1 by capital M plus 1 by small m is called the reduced mass. This reduced mass is inversely proportional to the alpha I. But that value will be denoting that 1 by m plus 1 by small m is mathematically minus 1. Okay, so this is actually mu ன்னு சொல்லுவோம். அதாவது reduced massங்கிறது என்னன்னா பாசிட்டிவ் அயனுக்கும் நெகட்டிவ் அயனுக்கும் இடையில supposed to just fixing with one individual mass, they are connecting with the individual mass is called reduced mass. According to center force theory, the reduced mass is going to be calculated as mu. Therefore, mu is equal to 1 by capital M plus 1 by small m whole power minus 1. So it should be also inversely proportional to the reduced mass of the particular ions. சரியா? அப்ப therefore ionic polarizability is also depends on the charge of the molecule, the square of the charge of the molecule, and also inversely proportional square of the natural frequency and also the reduced mass. Okay, so this are very simple calculations in that correspondingly the ionic solids. If you have to apply the electric field, the positive and negative displacements is going to be accountable with in that way. Each one of molecule is trying to come to the rest position. They are moving with the restoring force constant. The force can exist due to vibrating the positive cation and anion molecule. So in this way the x1 and x2 will be calculated. Finally the dipole moment of the molecule is connecting with E into x1 plus x2. So from that finally we just calculate alpha I is equal to mu by E. So from that we can derive the polarizability of that media. It's very simple calculations. Okay, so finally these are the things we'll discuss today. This final expression, final summary of the today's talk is the ionic polarization has occurred in that dielectric material below that optical range of electric field. Okay, so here you just apply the electric field in the ionic solid. Positive and negative ions separation is going to be disturbed. So actual there is a small displacement of the positive and negative ions has been possible. So from that the displacement, the dipole moment in that molecule is calculated as a charge into the displacement of the molecule. Okay, the x1 and x2 will be calculated from the way of restoring force constant. The restoring force is nothing but the force exists due to the force gaining that of force is trying to come to take a rest. The gaining of the force, the try to come to take a rest as like a harmonic oscillator. ஒரு சிம்பிள் ஹார்மோனிக் ஆசிலேட்டர் மாதிரி ஒரு ஃபோர்ஸ் கொடுத்தோம் அப்படின்னா அந்த எனர்ஜியை பூரா கெயின் பண்ணிட்டு அதை வந்து கம்ப்ளீட்டா ரிலீஸ் பண்ணும். அந்த மாதிரி எலக்ட்ரிக் ஃபீல்ட்னால அந்த ஃபோர்ஸை வாங்கிட்டு அந்த அயான்ஸ் வாங்கிட்டு அந்த அயான்ஸோட டிஸ்பிளேஸ்மெண்ட்ல அந்த பகுதியில இருந்து ஒரிஜினல் டிஸ்பிளேஸ்மெண்ட்டுக்கு வர்றதுக்கு அந்த அயான்ஸ் வந்து மூவ் ஆகும். That like a simple harmonic vibration. The positive and you just imagine that positive and negative ions can vibrate on both sides as a harmonic oscillator. Therefore, you just derive the force on the positive and negative ions is it be relating to the restoring force constants beta 1 and beta 2. Okay, so finally we just conclude that ionic polarization is nothing but E squared by omega naught squared into 1 by capital M plus 1 by small m. Okay, but that is inversely proportional to the square of the natural frequency and also the reduced mass of the ion systems. Okay, right. But these are the things we'll discuss today. So, any doubts in this regard, please ask. சிம்பிளான ஐடியா தான். அதாவது இதுல என்ன ஏன் செயினை போட்டிருக்கோம் அப்படின்னா, இட்ஸ் லைக் a harmonic oscillator. It's like a spring like nature. Positive and negative ions is like a spring like nature. But if you want to apply the electric, without applying electric field, the spring like nature will have fixed in position. So here you just apply that electric field, there will be a spring is going to elongated, and also it tried to come to the original position. This is called a restoring force constant is going to be applied due to applying electric field, the particular electric field in that case, in that particularly ionic solids. அதுல இருந்து நம்ம ionic polarization டெரைவ் பண்றோம். அதாவது அதோட displacement x1 x2 ங்கிறது charge of the particle, but that you are connecting with induced dipole moment is E into x1 plus x2. x1 is calculated individually, x2 is calculated individually by using the restoring force constant technique, F by beta 1 and F by beta 2. இதுல இருந்து x1 x2 கண்டுபிடிக்கிறோம். அந்த x1 x2 ஆட் பண்ணோம் அப்படின்னா ஃபைனலா mu வேல்யூக்கு கொண்டு வந்துரும். அப்ப therefore ஃபைனலா ஆல்பா i எப்படி டிஃபைன் பண்றோம்னா, இன்டியூஸ் டைபோல் மொமெண்ட்டுக்கும் எதை டிபெண்ட் பண்ணி இருக்கும், ஒரு எலக்ட்ரிக் ஃபீல்ட டிபெண்ட் பண்ணி இருக்கும். அதுக்கு இடையில ஒரு கான்ஸ்டன்ட் சேர்ப்போம், திஸ் இஸ் கால்ட் ஆல்பா i. இது அயனிக் போலரைசேஷன் ஆல்பா ஐன்றோம். ஆல்பா i is equal to mu by capital E. E is nothing but an electric field applied to the material. Mu is a induced dipole moment. Automatically நம்ம calculate பண்ணும்போது இந்த வேல்யூவை reach பண்றோம். Okay. So these are things we'll discuss today. There is any queries? Okay, stop here. There is no queries. I stop my talk in this level. Thank you very much for your patient listening.
Thank you, sir.